In this last video for aldehydes and ketones, we're going to take a look at optical isomers and the nucleophilic addition mechanism. So what we need to be thinking about here is the mechanisms that we've just been studying when we add to aldehydes or unsymmetrical ketones with KCN followed by dilute acid, then we're going to get optical isomers. We're going to get a racemic mixture of the two enantiomers. And remember that a racemic mixture is an equal mix, a 50-50 mix of the two enantiomers. So enantiomers are our optical isomers, and remember our definition of optical isomers is non-superimposable mirror images. So these are our key words. Make sure you're keeping up to date with your key terms in chemistry. So let's just review the mechanism of an aldehyde with KCN followed by dilute acid. So remember, an aldehyde has a R group, C double bond O, and a hydrogen, and our KCN is the source of the cyanide nucleophile. So in that goes to the double bond because the carbon is delta plus, because oxygen is more electron negative. Break the pi bond, put the electrons onto the oxygen. We have added so far the CN. The H is still there. The oxygen's become an O minus with a lone pair, and we're going to now add the followed by dilute acid in our reagents and conditions. So we're going to add the acid, the proton, to make the hydroxynitrile. And what we can see here is that we have got a chiral carbon, a carbon with 4 different groups attached, and therefore a carbon that will have optical isomers. So we've got 4 different groups, and so we can show those optical isomers. If you've forgotten how to do this, go back and have a look at your optical isomerism pack. I'm going to put my R group at the top here and reflect it over here. My hydrogen and my cyanide. My hydrogen. Now remember that cyanide has to have some good connectivity, so we do need the C before the bonded to the C. And then I've got a hydroxyl group, a hydroxy group over here. So I'm going to reflect that. So 4 groups, got non-superimposable mirror image isomers of each other, optical isomers. So how does the shape of that aldehyde or the unsymmetrical ketone lead to an equal mixture of both enantiomers? And remember that equal mixture is our racemic mixture. And our racemic mixture will not rotate plane polarised light. Despite each enantiomer being able to do it, the racemic mixture won't. So what was it about the shape? So it's all to do with finding something in that structure that's planar. And right here in the aldehyde, we've got a planar carbonyl carbon. So let's go back. The carbonyl carbon is planar. That's the C with the double bond O and the stick. That carbon there is planar. So the nucleophile, and in this case the nucleophile is our cyanide ion, can attack equally from above or below plane, giving a racemic mixture. This mixture will not rotate plane polarised light despite containing chiral carbons. Squeeze that in there. So what I'm going to do is pause the video, have a go of that mechanism with pentan 2-one again, and draw me the two non-superimposable mirror image isomers of the product. So here's our mechanism, and you can see what I've done is I've highlighted out the chiral carbon and the 4 different groups. I just need to go back and change the colour of one of those so that we've got 4 different colours there. So we've got 4 different groups, and what we're going to do is we're going to try to draw the non-superimposable mirror images. Now if you remember from a previous video, my top tip on this is to make sure you can do your tetrahedral shape beautifully, and then always put the most complicated or the longest, biggest group at the top, easier to reflect, and the ones that are smaller down here, and you can put these in any real order you like, just making it easier for yourself because you're going to draw a mirror image of it. So having the biggest one here, which was our blue group up there, and our small ones here close to the mirror, make it easier. So although the structure forms with a chiral carbon, the actual mixture will not rotate plane polarised light because it is racemic. That's the end of this little short video on aldehydes and ketones and optical isomers.